because the people are sitting there. On the slide.
Welcome everyone, I'm Norman Wapper, and today I want to invite you to join the community that's going to be going through Algebraic Calculus 1, the first of our Algebraic Calculus courses. So I want to provide you with some information about the setup of this course. I decided that it's going to start on January 1st, 2018, which seems like a good time to start the course, and it will be on the Open Learning platform, which is completely online. Now, this first Algebraic Calculus course will be almost principally about the integral calculus. That's what we're going to do first. In our second course, we're going to deal with the differential calculus, which is actually more subtle and more difficult than the integral calculus. It's usually thought to be the other way around, but I think we can change our mind about that. And of course, we're going to present a dramatically new way of thinking about this subject. It's important to realize that conceptually we are going to retreat from a lot of axiomatic and dubious or questionable current practices. So I want to return to a more solid, elementary, sort of high school orientation. So I'm going to assume that you've finished high school and that you're solidly grounded in algebra, in arithmetic and in algebra, and that you have some familiarity with essential geometry. I'm not going to assume that you know anything about calculus, and I'm not going to assume that we're going to adopt the usual kinds of assumptions that underlie typical calculus courses, namely assuming that we already have a ready-made continuum at our disposal that we can just build on. I'm also not going to assume that we know the meanings of a lot of crucial words. So for us, the definitions are all important, and we're going to be very careful about the meanings of all the words that we use, especially the mathematically central words. But in any case, there's not going to be any infinite processes. We're not going to allow ourselves to complete an infinite number of tasks in principle and pretend that we can create an output from such an infinite process. There's not going to be any real numbers. I consider the arithmetic of real numbers as basically a vacuous theory. It's a kind of a big gaping hole in the center of modern mathematics that everyone skirts around, pretends it's not there. So we're going to avoid that. We're not going to harp on about these things, but it's really important that when you're starting, before you start, that you recognize that this is going to be my orientation. So we really are going to avoid those things. We're just not even going to mention them. Okay, there's not going to be important for us to make contact with so-called real numbers or irrational numbers or set theoretic, fanciful things. The course itself is going to consist of videos first, and worked examples on the Open Learning platform. There'll be lots of diagrams. There'll be homework problems for you to do and to work through. There'll be discussion forums where we can discuss all the very interesting things that are going to be going on here. So it's really a full-fledged course, but it's all online. So the course itself is designed to have the content roughly of a 10 to 12 week first-year university semester course. So it's typically the level, the content, the amount of effort required to take a solid first-year course in university, which lasts one semester, or 10 to 12 weeks. But our course is going to be actually spread over a year. So what we're going to do is we're going to develop it every month. We're going to develop one of the weeks of this, say, 12-week course. All right. So that means that the course will be spread out because we're going to be developing it as we go. So it's not that the course will be completely finished by January 1st. I'm going to be creating it as we go, and that's enough time so that I can reasonably, hopefully, try to do that. So that's the aim anyway. There may be a little bit of flexibility there. So by the end of 2018, you will have finished this course, and it will be equivalent to roughly a solid full first-year semester course. The first run, this 2018 run, will be very special because I'm thinking this is like a beta version. So this is a work in progress. We're putting this course together, and I'm really hoping that the community that joins me in this will contribute to the development of this course. And that will be a big aspect of this. So I'm going to be asking you not just to do work, to do the exercises and so on, but also to give me feedback, to give me suggestions, and to actually make mathematical contributions. Okay? And that's going to be very important. It's going to be a great opportunity for you to really make interesting discoveries because we're going to be thinking about things in a dramatically new way. So there'll be huge opportunities for clever young people, or clever not so young people, to really engage with cutting-edge mathematics, like new mathematics that's really reshaping the landscape. And you'll be able to make contributions if you work hard. That's very exciting. And I fully intend to acknowledge people's contributions. So if you make a contribution, you submit a new problem, I'm going to put that problem up there, and your name will be probably beside it. Okay? So I want this to be something of a collective effort. It's a work in progress. I will be guiding it, but you'll help me, and we'll create a fabulous, interesting course. Now, in terms of who's going to be in this course, well, my intention is that this will be by invitation only to my Patreon supporters. So let me say a little bit about that, okay? So I'm not going to open this course to the general public. I want the people in this course to be serious and focused, and that we have a sense of community. And I think the best way of doing that is to go through my Patreon channel. And so let me say a little bit about that. Okay, so what is Patreon? Patreon is a site that allows people to support creators. And they can be creators making music videos or cartoons or artworks or, in my case, mathematical videos. And here is the URL for that. So that's my Patreon page. And that is where people can go to support my YouTube activities. So typically what you do, a supporter will pledge a certain amount of money for every video that I make. And the minimum is $1 per video. So if you pledge $1 per video, and you can have a specified monthly maximum, so you can say maximum of $6 a month. Well, then you're supporting my channel, and you're supporting my activities. And so what I want to do is to encourage you to think about becoming a supporter of my channel through this medium. And then my intention is that invitations to Algebraic Calculus 1 will be sent to established patrons. Established patrons meaning, say, somebody who has contributed up to $20 or more by the time January 1st rolls around. And they're also continuing patrons. So established and continuing patrons, and I'm going to invite them, and also some select others. This will ensure that we have a group of people that I think are sort of like-minded and that are generally positively oriented to what I'm doing. And I think that means that we can have a healthy conversation, and we don't need to get distracted in fights and little spats and such. And we can really concentrate on this important job of rolling out mathematics for essentially the new millennium. That's what we're doing here. It's a very important historical occasion. So this is a great opportunity at a very minimal cost. And this course is going to be comparable to a course that you take at a university, which will cost 10 times as much typically. And on many levels, it will be at least as good, let's say. Okay. And I'm hoping that you'll find that it's every bit as good as calculus courses that you can find at the top universities in the world. I'm aiming very high here. Okay. I'm aiming this to be the benchmark by which all subsequent calculus courses are judged. So please think about it. I know a lot of people think that everything on the web should be free, and I have some sympathy for that, and I think no one can accuse me of not having put a lot of freely available material up on the web. But this is more than just a bunch of videos. This is actually a lot of work required to set up lots of examples, to set up text, to set up explanations, diagrams, to create homework problems, to think the whole thing through. So it's a huge amount of work, and I think it's not unreasonable that people who want to participate in it make a contribution. So I'm asking you to think seriously about joining our community to support this effort. Now, the videos of the course will be the scaffolding for the course, but that's just one of a number of different resources that will be available to you. And because of that, I'm going to make the videos perhaps a little bit less detailed or a little bit less comprehensive than they usually are. So usually I try to say everything that needs to be said in the videos. But here I'm going to also reserve places for explanations in other places, typically in the text, or in the diagrams, or in the examples or problem sets that accompany the course. The videos themselves will be initially posted on this YouTube channel, this sort of second channel that I have, Wild Egg Mathematics Courses. So it's sort of a sister channel to the NJ Whopper channel that you're watching now. Here is the URL for the channel. But I have to warn you that only selected videos in the series, in this course, will be accessible publicly. Okay, so I'm not promising to put all the videos up there. Some selected number will be, but not the entire course. So if you want to participate in the entire course, you want to join our Patreon community. But still, you will still get a fair idea about the direction that we're going and some of the exciting things that are happening by the videos that I do post. All right, so for the course participants, this, I think, really represents a great opportunity. So it's an opportunity to learn calculus in a new and exciting way. It's really going to be new, and it's really going to be exciting. But it's also a chance, as I said, to make important contributions yourself to the development of this new direction. Okay, so we are taking an established subject, and we're looking at it with new eyes, and we're seeing all kinds of new aspects, and you can be major contributors. Really great opportunity. So to get into a research kind of environment at the same time as you're learning. So you're learning, you're experimenting, you're making some computations, you make some small discoveries, we share it, other people add, and we end up really creating something really interesting. So this is part of a historic occasion, and I would like you to be part of it. I really think people will look back on this time and say, yeah, what was happening in 2018 was the algebraic calculus. That was the main event. So be part of it. It's also a chance to join a community, make friends, engage in discussion, make suggestions and comments, and I'm hoping we'll have a collegial atmosphere. So things are by invitation only, so if somebody's coming unruly, then I would just ask them to leave the course. That will not be a problem. All right. So we're going to have a very pleasant time here, and I think it's going to be a lot of fun. And so here's a bit of orientation, or maybe some rules that will help us guide us in developing the course. So first of all, no idle philosophizing. Philosophizing is great, but this is a mathematics course. We want to stick with mathematics. No real numbers, axioms of set theory, infinite processes. So we're not going to allow discussion where people start using these words as if they have some prior meaning. So for us, these are all concepts which are dubious, and so they don't really belong to the discussion. They're not part of what we're doing. So I'm going to encourage us to put that aside, leave that outside, and come in, take off your shoes, and it's nice carpet here, and we're going to try to work in the framework that we're creating here. Okay, so it's going to be independent of these for me, questionable things, but you don't have to think they're questionable. We're just not going to deal with them. But we are going to have prior agreement on the crucial importance of the definitions. Okay, that is something that I want us all to share. The importance of defining terms before we start using them. So we're not allowed to use even relatively simple terms, even very seemingly familiar terms, like number, sequence. These kinds of terms, I know we don't think we know what they are, but it's very, very subtle, actually pinning them down. And until we do pin them down explicitly and concretely, we are going to treat them with deference and maybe a little bit of suspicion. Okay, so that's going to be our orientation. We're not going to assume prior understanding of mathematical terms, unless they're from high school, having to do with arithmetic and algebra. And we'll be reasonably clear about what those are. Okay, so we'll have some preliminary videos that set out what are the assumptions and the framework that we're working with. We have a lot of respect and admiration for explicit examples and concrete computations. Two of my favorite things in mathematics. Really show good examples because you have a really good look explicitly, concretely. Concrete computations, so you can actually see what's going on step by step. It's unfolding right in front of your eyes. It's not off the page. It's not at the end of time or beyond our universe somewhere. No, it's happening right here on the page where we can all witness it and check it. And I'd like to offer a special invitation to my fellow mathematicians who are teaching at universities. I would really like you to join us as well. And so I have a kind of a special deal for you. So first of all, if you can join the course, and I really hope you do, you will learn a lot. I guarantee you this. Okay? It will not be the same kind of calculus that you're familiar with. It will be different, but you will see the advantages. Okay? So it's going to be a new experience. In fact, it may even be more challenging for you. Probably will be more challenging for you than for a first-year undergraduate who has not had calculus before. Because you have learned calculus so well and have such familiarity with it that to give up that standard orientation and to look at things in a different way, with a new perspective, with a new set of eyes, that will be very challenging for you. But it's also really exciting. Okay, so have a go. And I really do want your contributions and insights. I am confident that you are going to have great insights and suggestions to make the course better. Okay, so I really want you to join us. So to make that simpler for you, please send me an email from your institution and set up an open learning account with your real name, and I'll sign you up or join you up for free. Okay, so you don't have to become a Patreon supporter if you don't want to. You can, of course, if you want to. But if you're a bona fide mathematician teaching at an established university, then I'm happy for you to join the course for free. I hope that I can get some of you to do that. But let's do it under your name so that we all know who we are, and we can have a kind of an open, direct discussion. Okay, so how should you prepare? Well, there's a few things that you can do between now and January 1st, 2018. One of the things I would suggest is to download GeoGebra if you haven't done that already. It's a free program, and it's a dynamic geometry package, but it's also quite flexible. It has some other aspects and tools that are important for us. And the other thing is to get a computer algebra system, a sort of computational environment that will allow you to do not only arithmetic, but symbolic algebra. So probably amongst those, there's lots of them, but Maple and Mathematica are probably the leaders in the field, but there's MuPad and MATLAB, and there's quite a few others. There's FryCAS and quite a few others as well. So some of them cost some money, others are free. That one's free, I think. And that's a really important tool because we are going to be dealing with algebra, and it's really great to have some tools that allow us to make simplifications of formidable-looking algebraic formulas. That's part of the story of the algebraic calculus. We are going to be using algebra. Okay, so having a kind of a tool that helps us with polynomial arithmetic, typically, that's going to be very valuable. And if you haven't done so already, you can start watching the Wildland Alge series, which is about linear algebra. So linear algebra is going to be brought together with calculus in this course. There's going to be a lot stronger connection between those two subjects than there traditionally is in a calculus course. So usually at university there's calculus and there's linear algebra and there's not that much connection. In our course there will be a lot of connection, and so that's, I think, a pretty good introduction to that course. Of course, Math Foundations, where you get a sense of why it is that I'm concerned with real numbers and infinite processes and a lot of other things, and that'll give you some kind of orientation to the general direction in which the course is facing. But I want to emphasize that I'm not going to be spending a lot of time talking about the things that I talk about in Math Foundations. So we're not going to have extended discussions about the pros and cons of axiomatic systems. We are going to learn calculus in a particular way, and that's what we're going to focus on. The Maths History series, I think, is also great for students who are about at the level of sort of entering first-year university, making that transition. I think that's gives you a larger view, of the history, who's thinking what at what time. I think that's great motivation. And a lot of the things that we're going to be doing in this course are connected with historical stuff. It's not that we're just creating this independent of anybody else. We're going back to Archimedes, you'll see. We're going to go back to Archimedes. We're going to go back to Newton and to Leibniz and to Lagrange and Euler and the Bernoullis and Gauss. And we're going to really try to extract the great insights that those people had, and probably more so than almost your typical calculus course. Right? We are going to be very historically oriented, but we are going to have a modern build-up of some of those ideas. Okay. And here's something else that you can do. Okay. Take some long walks, meditate a little bit, and try to free your mind from prior conceptions. Okay. We are going to have to think in a new way, and it requires some courage to put aside standard thinking. Just because everybody's thinking in this direction, there's a status quo and there's a uniformity of thought with regard to modern calculus courses. In fact, a lot of calculus books look very much the same. And there's a lot of pressure on undergraduate lecturers to present a calculus course which is not dramatically different from other calculus courses. There's this feeling that the engineers want this and then they require that. But we're kind of free from that, right? So we're not, having some agenda imposed on us. So I can just develop the subject in a way that I think is best in terms of the actual logical structure of the subject. And that means that it's going to look very different in terms of the topics that we cover and the sequence that we talk about them with. So it's going to be very different, and I want you to have an open mind about that, to be prepared, to think differently, to think in a new way, to think in a 21st century fashion, because this is calculus for a new millennium that we're going to create here. So I hope you're going to all join me for this. Thanks for listening. I'm Norman Waldner. I'm Norman Waldner, and welcome to the Algebraic Calculus. This course is a new and more exciting and logical way of thinking about this important subject. In today's lecture, we want to look at points and lines in the affine plane. This is kind of an introduction to the basic geometrical framework in which we're going to position calculus. We'll see that there's natural connections with ideas from linear algebra, and we will take a somewhat linear algebraic point of view to things. We'll also have a look at the projective version of looking at points and lines, which will be an important and powerful tool that will allow us to quickly solve some interesting problems. Okay, so the basic idea is that algebraic calculus is very closely associated to linear algebra, this great 20th century contribution to mathematics. And geometrically, the setting is what we might call the affine plane, which is a lot like a sheet of graph paper, but we have to have a slightly more flexible approach to what this actually is. So the idea is that we're going to use parallelism. We're going to adopt the idea of having parallelism, but not necessarily perpendicularity or any metrical notions like distance or angle. So when we just have parallelism and lines, we can start with two particular lines, say the x and y axes, and then we can consider equally spaced other parallel lines parallel to those. So say parallel to the x-axis, we have these other lines which are all parallel to it and equally spaced. And parallel to the y-axis, we have these other lines which are also parallel to it and equally spaced. So this is our basic framework for affine geometry. We might call it the affine plane, or sometimes the affine grid plane. And it's a familiar enough kind of arena, except that you'll know that I'm not actually going to be that fussed about having these two axes perpendicular, because we're kind of going to assume that we don't have any notion of perpendicularity floating around here, at least initially. Nevertheless, we can mark along either of these two coordinate axes, we can mark out coordinates, starting with 0 where they meet, and then 1, 2, 3, and so on, and in the other direction, -1, -2, and so on. And similarly in the y direction. And that allows us, in a way that's, I hope, very familiar to you, to be able to associate points, like say 3, 2, with actual positions on the plane. So 3, 2 means that we go over 3 in this direction, go up 2 in this direction, and then we're going to use these parallel lines to find the point A. So we go over to the 3, and then we choose a parallel line to the y-axis. We go up 2, and then choose a line parallel to the x-axis, and where these two lines meet, that's our point A equals 3, 2. Over here would be B equals -1, -2, and notably the origin is the point 0, 0. So that's the reasonably familiar affine plane, but a slightly more general version where we're allowing a little bit more flexibility in the relative positions and scales on the x and y axis. It's an important flexibility that's going to be very useful for us as we develop calculus. So having pictures is, of course, very nice and very important, but we also want to have official definitions that pin things down very precisely. That's going to be an important aspect of this course, is that we're going to strive towards really clarifying what the essential definitions of the main object. Pictorial understanding of points. Let's now give a precise algebraic definition of what a point is, or more precisely, an affine point. Okay, so an affine point, say A equals x, y, is a pair of rational numbers in square brackets. Okay. So we are adopting a very